Hi, in today's video, I'm going to show you this internal project I've been working on. Basically, I built this e-commerce website specifically to practice and demonstrate API security design. Well, as you can see, it looks just like any other famous shopping website like Amazon or Shopee or Taobao. Actually, we've got all of these basic features. For example, up here at the top, we have a category bar where you can easily choose any category you want. For example, we have laptops and computers over here. We also have smartphones and headphones, as well as watches. And of course, at the beginning, the shopping cart is empty, right? And let's say if you want to buy an Apple Watch Series 8, you can just add it to your cart. And also, if you want to buy a Galaxy Watch 5, you can do the same thing. And whether you want to buy two or three, or just go back to one, everything looks pretty easy, right? Well, and of course, one principle is that you have to log in to check out. And also, for your first visit, you have to click on this sign up button to register your own account. And in the future, after signing up for the first time, you can just click on this login button to start your shopping trip. Well, everything looks pretty standard so far, right? But what I have to mention is that there is a very interesting and special feature here, which is this, the security lab. Well, as for the reason why I set up this security lab is that, API security is mostly backend stuff, right? And I've always struggled with how can I actually demonstrate it? You can't just point at some code and say, oh, this is bad or this is good. It's not very direct or clear at all, right? So I was thinking, why not set up a specific page in our site where I can show you, real attacks happening. Then I can easily flip to secure mode and show you how we stop them. So it's more like having a live security demo right in your browser, right? So as you can see, we are in insecure mode by default, and there are actually two different modes, secure mode and insecure mode. You can easily switch between them by simply clicking this switch button right here. So let me show you what's going to happen inside the security lab. Basically, I've listed some typical API security attacks and also demonstration of how GraphQL blocks them. All right, let's get started with our first vulnerability, which is data overexposure. Well, this is actually one of the most common OWASP top 10 security issues, which is the server may return too much sensitive information. And in today's scenario, when we query about product list from the server, it may include like internal IDs, detailed descriptions, and some of other sensitive business data that should never be exposed to end users. So right now we're in secure mode. So let me first click this fetch product data button to show you what is gonna happen. So look at this secure response. In secure mode, we only get the essential information that users actually need. For example, we got these product names, their prices, and their stocks, and also their categories. So the thing is, no sensitive business data exposed. This completely follows the data minimization principle, which is only return what's absolutely necessary for the user interface to function. So let me show you what is going to happen when we have a data overexposure vulnerability. So let's switch to insecure mode. Now we are in insecure mode. So let me do the same thing. So look at this red columns, look at this critical security breach. Now we are getting way too much sensitive information. We've got internal costs, their suppliers, and also their warehouse locations. So this is exactly what data overexposure looks like. The API is leaking sensitive internal business information that should never be visible to end users. And as you can see in the security analysis, this may create multiple attack vectors. For example, first of all, competitors can see our cost structure and our profit margins, and also supply chain information could be used for targeted attacks. So in a real world scenario, this kind of data leak could cause some of other risks. So this is why proper API security and data minimization are absolutely critical. Now, let's move on to the second vulnerability, which is order history leak. Well, this is a very classic example of broken access control, which is actually the first vulnerability in the OWASP top 10. So, specifically in a proper secure e-commerce system, users should only be able to access their own order history after logging in. However, when access controls are weak or improperly implemented, users might be able to view other users' sensitive order information. So let me demonstrate this. First of all, let me try to click this access order history button and let's see what is going to happen. So right now we're in secure mode, right? So when I try to access the order history, as you can see, access denied, telling me that you can only get it after logging in. And also, the system correctly redirects me to the login page because I'm not authenticated, right? So let me follow the rule and see what is going to happen. So let me type in my email and type in my password, then submit. Then let's go back to the security lab and see what is going to happen. So let me try it again. So perfect. After logging in, I can see my own order history. And how about we just switch back to insecure mode? And let's see what is going to happen if I try the same thing. For example, I click this access order history button. Oh, look at this. The system easily allowed me to get the order history for Ledger Hot even without any login. So actually, this is extremely dangerous because anyone can view order history without any authentication. So as a result, customer personal information exposed, and also purchase patterns and some business data can be stolen easily. So this is also why proper access control is absolutely critical. That is, every sensitive page must require user authentication and permission checks. Now let's move on to the next vulnerability, which is SQL injection attack. This is actually one of the most dangerous attacks because it can completely bypass authentication. And at this time, for this vulnerability, I would show you another way, where I would go to the TechMart, which is our main system, and firstly, I will go to the sign up page to register my own account. Let's say my first name is Bob and my last name is Smith and my email is bob@gmail.com. And I will set my password as, for example, 20010213 Bob, and then I submit. Alright, now we have a real account for Bob Smith. So let me just log out and show you the SQL injection attack. And look at this login page. Let me show you what I'm gonna do to do SQL injection attack. Well, just imagine I'm the another person who doesn't know the real password for Bob Smith at all. And the only thing I know is Bob's email, which is bob@gmail.com. Since I don't know his real password, so I just type in 123 or whatever, and then I would append this sentence at the end, and then I would try to submit. Amazing, it worked. I just logged in without even knowing the correct password. So let's just go back to the security lab and let me explain what happened here. First of all, the original database query looks like this. Select from users where email equals blah blah and password equals blah blah. But with my injection, it becomes select from users where email equals blah blah or 1 equals 1. Since 1 equals 1 is always true, the OR condition makes the entire where clause true. So it actually bypasses the password check completely. And what's more, the double dash comments out the rest of the query, so the password part is ignored. And actually, this is extremely dangerous because hackers can access any user account without even knowing the password. The only thing they need to know is a valid email address. And then let's switch back to secure mode, where I will show you how we prevent this. So firstly, I will go to this login page again and do the same thing as we did in insecure mode, where I would type in this whole sentence, and then I would type in any password like 123 or whatever, and then I try to submit. See, it's blocked. So the thing is, in secure mode, we use parameterized queries that treat user input as data instead of part of the SQL command. So this is completely prevents SQL injection attacks. Now let's move on to another vulnerability, which is cross-site scripting, or XSS for short. This is actually another really dangerous attack because it can steal user information and execute malicious code right in their browser. So here's how this attack works. If you want to see the full demonstration, you can refer to the tutorial on this page. But let me walk you through it. First of all, you need to click any product to enter the detail page. And secondly, scroll to the review area at the bottom of the page. And third, enter XSS attack payload in the review box. And fourth, finally submit the review and observe the result. So first of all, let me just generate an XSS attack payload for you. So the system generated a malicious script. This is actually a sentence of HTML code. So when users post this as a comment, what will happen? So let me copy it and go to a product review section. So this is our main system. So I will choose this iPhone 14. And then I will, this is a review box over here, and I will enter what I have copied into this box and give it a rating and then submit. So see what happened. The comment now appears as a clickable blue link that says click to visit malicious site. This is actually a demo. So when I try to click it, I was redirected to another website. So as you can see, the scary part is that this looks completely normal. Users will think it's just a regular link, or they don't think it's a link, but it's actually executing JavaScript code that redirects them to a potentially dangerous site. So let me first explain why this works. So the main reason it displays as a web page link is because the browser interprets the sentence of HTML code. And so the onClick attribute makes it clickable, and the style attribute makes it looks like a blue underline link. So when someone clicks it, the window.open function executes and opens a new tab. So how about we switch back to secure mode? So in secure mode, let me try the same thing. Oh, and as you can see, in secure mode, all user input is sanitized. So in another word, HTML tags are stripped out, JavaScript is removed, and only plain text is stored. So this malicious link will just appear as a plain text. So in a conclusion, the key principle here is never trust user input, always sanitize, and validate everything that comes from users before displaying it on your website. Now, let's move on to today's last case, which is payment security. Actually, this category is one of the most critical areas in e-commerce system because it directly impacts business revenue and also customer trust. So literally in payment systems, there are typically four major types of vulnerabilities. And first of all, price manipulation attack, where attackers modify payment amounts sent by client to purchase high-value items at extremely low prices. And secondly, payment bypass attack, where unauthenticated users attempt to process payments, bypassing authentication. This is also very classic. The third one is payment status manipulation, where regular users attempt to modify payment status, such as changing paid to refunded. And last but not least, payment information leak, where attackers query all payment records, including other users' sensitive information, which would probably cause, for example, privacy leak and also payment information overexposure. Well, due to time constraints, I will only demonstrate the first one, which is also the most critical and most dangerous payment attack, because it will absolutely cause direct financial losses to our business, which is rather fatal, right? So here is actually a tutorial of hackers attack steps over here. So in today's video, I'm gonna follow these steps to demonstrate the whole thing. So first of all, I would go back to our main system and add this MacBook Pro, which is nearly $2,000, and I will add it to my cart, and then I will go back to Security Lab. Then I'm gonna click this button and let's see what's gonna happen. So there we go. Look at this. I'm now being redirected to Stripe checkout, but notice the price has been changed to just $1. So I can literally now purchase a nearly 2000 MacBook Pro for only $1. Actually, this is extremely dangerous because it allows attackers to buy really expensive products at virtually no cost, causing, massive financial losses to the business. So let's go back to the security lab and explain what happened. So actually, the vulnerable server trusted this client-sent price data and created a Stripe checkout session using my own price instead of the real price from the database. And let's think about how about we just switch back to secure mode and see what is going to happen. So great. Right now we're in secure mode and let's try the same thing again. First of all, I will go back to TechMart and I will add this MacBook Pro to my cart. Oops. Actually, in secure mode, we have to log in before adding items to my cart or before checking out. So let's just log in first. This is my email and this, and I will enter my password and submit. Great. Right now we have successfully logged in and let's try the same thing again. And now the MacBook Pro is successfully added to my cart. So let's go back to Security Lab and click the same button over here. Oh, great. The price remains correct, which is nearly $2,000. So that is in secure mode. The server follows a fundamental security principle, which is never trust client-side data for critical operations. So let's go back to Security Lab and explain the whole principle. So in a conclusion, the key security principle here is server-side validation and authoritative data sources. That is, all critical business logic, especially financial calculations, must be performed on the server side using, trusted data sources. So never relying on client input. Well, actually, we also have another case of vulnerability over here, which is shopping cart authorization bypass, um, which allows any users to access and modify shopping cart data without any proper authentication. However, since we have already demonstrated in our previous payment security demo, so let's just skip it. But I'll say the core principle is the same, which is the system fails to properly verify user permissions before allowing access to sensitive operations. So let's move on to the next part. Let's just have a takeaways and conclusion so far. So, throughout today's demonstration, we've seen how the same application behaves completely differently depending on the security mode is running in. So for example, in insecure mode, we successfully executed multiple attacks. For example, first of all, SQL injection and also XSS attacks and also price manipulation and also data overexposure. But when we switch back to secure mode, every single one of these attacks was blocked. So as you can see, the same application, the same interface, but completely different security posture. So in this page, there are a lot of principles and key points in terms of comparison between two security modes, but let me just conclude it. First of all, never trust client-side data, which means always validate and sanitize on the server side. And second of all, be careful. Must use parameterized queries and prepared statements to prevent SQL injection. And third of all, implement proper input validation and output encoding to just prevent XSS attack. And fourth of all, always use verified data sources for critical operations like pricing and payments, which is very critical and important. And finally, last but not least, security is not a one-time implementation, which means it's an ongoing process that requires our constant effort and constant updates. Well, at the end of today's video, let's quickly look at GraphQL advantages in data protection and privacy. Well, actually, GraphQL has significant advantages in API security design through its strong type system, process queries, and built-in validation mechanisms, which effectively prevent common security vulnerabilities. So let me just demonstrate this by comparing RESTful API and GraphQL responses using the buttons below. So first of all, let's click this RESTful button for product list. So we can notice that what we get back from the RESTful API, it's a complete fixed data structure with all available fields. So this is a very typical RESTful behavior where the server decides what data to send. But now, how about we click the same button for GraphQL? So as you can see, the whole difference with GraphQL, we get exactly what we requested, no more, no less. So the thing is, we have process control over the data structure and fields returned. So let's move on to the table here, where I compared some features between RESTful API and GraphQL API. So there are a lot of things over here, but let me conclude it. So the first thing is data minimization, which is GraphQL's process field selection reduces data exposure following the principle of least privilege. And second of all, query flexibility, which is instead of multiple REST endpoints, GraphQL uses a single endpoint with customized queries. And thirdly, built-in validation, which means GraphQL's type system automatically validates the query structure and field types. So, and as you can see in our best practices section, GraphQL provides additional security features like field level permissions, query depth limiting, and complexity analysis, all of which contribute to a more secure API architecture. So as you can see, choosing the right API technology can significantly impact your application's security posture by controlling exactly what data gets exposed.